Okay, now let's graph y equals 1/2 to the x. We already said when the b is greater than 1, it's growth. Let's see what it looks like when b is less than 1. You could probably guess. Okay, I'm going to use these values of x, -2 to 2. Why? Because I get to choose. Right. So that will be 1/2 to the -2, which is like 1/2 to the -2. Right? How do I resolve a negative exponent? How do I simplify? You flip it to the other side of the fraction, right? If it's a negative exponent in the denominator, it's a positive exponent in the numerator, so it's 4. Same thing here, right? 1/2 to the -1 is 1/2 to the -1, right? But properties of exponents tells me if I move it to the numerator, it's 2 to the first. So it's 2. Okay. Let's plug in 0. What is 1/2 to the 0? 1. Anything to the 0 is 1. Okay, how about 1/2 to the 1? 1/2. And how about 1/2 squared? 1/4. So there's my 5 points. I'm going to graph them. And again, my values here go from 4 to 1/4. So I'm going to make this go up to 4. And I'll change that to blue. So here's my first point. -2,4 is here. -1,2 is here. 0,1 is here. 1/1/2 and 2 1/4. Right? Can we see the shape of the graph? More or less? Right? So it looks like this. Right? Is there anything, well, first, the basic shape of the graph now, it's decreasing from left to right. So when the b is less than 1, that's called exponential decay. Right? That is exponential decay. b less than 1 is exponential decay. It's decreasing. Is there, again, same question, is there any way for me to make that function equal 0? Anything I could plug in for x here that would have made this function, the y value, equal 0? And no, what you're going to see is just like that. Now it's these values get, as x becomes bigger in the negative direction, the y values get bigger positively. As x gets bigger to the right, it's going to get closer and closer and closer to 0, but it's never going to touch the x-axis. So we still have an asymptote on the x-axis. So I could draw that in. Here's our horizontal asymptote right there. Y equals 0. Right. What is the y-intercept? It's 1, right? It's this value right here. That's the y-intercept, is what you get when you plug in x equals 0. Now, most of the time when they give us an exponential decay, it'll look like that. It'll have a b which is less than 1, but not always. There's another way to represent that, and that is this. Right? If I wrote this like y equals 2 to the negative x, that is also exponential decay. Because again, how do I simplify raising to a negative exponent? Flip it to the other side of the fraction, right? If that's a 2 here, then it's 1/2 to the positive x, which is 1/2 to the x, which is the same thing as that. So it's the same thing. Saying 2 to the negative x or 1/2 to the positive x is the same thing. because the negative just flips it, the fraction anyway. Both of those are exponential decay. Most of the time in this book, they show that as decay, but not all the time. In the pre-cal book, most of the time they say decay is like this, but not all the time. They're both valid ways to show exponential decay.